Well, we're going to start this repair-a-thon of these 9 different chassis from the game gallery out in Pennsylvania with the 2 K7000s that were out of their 6-player X-Men. Now, I mentioned in the first part, which I guess isn't really part 1, but we'll call it part 1, I guess. This will be part 2, where the overview of the 9 different chassis where we open them all up and go through them and check them out and everything. I talked about how I really wasn't going to do much exposure here on this K7000s unless some kind of new anomaly came along. But I thought kind of better of it and thought, well, you know, it's going to be good to go ahead and show the owner of these, who I'm sending these back to, that everything is working on the back end. So if they receive them, they'll know it's something that happened in transit or on their end that caused it to not work when they get it. So I want to do these videos in like a 9-part series, or it might be, you know, 6 parts depending on how many chassis I work on in one video. But I want to do all these together in one playlist. And that way, normally I send videos of these repaired to the owners separately as like a personalized video so they can see that it's working before I box it up, send it back to them. Like I say, in case they get it and it doesn't work, they know it's not something on my end, it's something on their end or something happening in shipping. So I figured I'd go ahead and just do a review of what to check on the K7000s, because we're going to go ahead and treat these like we have no idea what's wrong with them. They may only simply need servicing, and they actually work just fine. But I want to go ahead and show all this stuff so we can have a little bit of a refresher, and also kind of to kill 2 birds with 1 stone for edification and information purposes, to shoot the videos on these, and then also so the owner of these knows that when I got done with them, they're in working condition in case something happens on the back end. Again, they know it's not anything that I did. And for my peace of mind too. So let's go ahead. This is the one that was marked as the number 2. It's the one that is missing the remote board, so we're going to set this one aside and just start with this one here that was in the one that was marked as number 1. I think it was number 1, I forget. Actually, this was chassis number 8, maybe? And the other one was 9. It doesn't matter. It doesn't ultimately matter. But anyway, this is the first one out of the X-Men, assuming the top monitor, because there's a top monitor that faces forward and one that's down that faces up, which is the bottom one. So this is the one out of the left side, regardless. So I did go through and wash these. So it's been 24 hours since I've washed them. And yeah, because we know from the first part, if you watch that one, this will be in a big playlist, and I'll you know, link the playlist in the description once they're all done, if you will. But this is the all of them were filthy, but this is one of the ones that was really dirty. So I went ahead and cleaned both of these so we can have a good clean test bed to go ahead and start with. And it looks like all the components are here. Some caps, no, looks like all these caps are original. I think the other ones someone had done a cap kit on, but these all appear to be original. And if we look on the bottom side, I have a little bit of hard water here in Kansas, so we have stuff like this going on, but nothing a little brush won't take care of. So yeah, this appears to be completely untouched by anybody. I'll be the first person to work on it, so that's great. So let's just treat these like we have no idea what's wrong. If they're not working, we don't know. So let's pretend like we have no idea, which I guess we really don't. But we're going to start by going through all of the normal testing procedures you would get, or you would do when you get a 7000 that you're unfamiliar with and have no history of. So the fuse is not blown, and we did verify it is an actual 2 amp fuse. Yep, 2A, so that's good. You always want to make sure someone hasn't overrated the fuse, because I found a 5 amp fuse on one of them in the video where we went over all this stuff. So we'll start off by making sure the fuse is good and make sure that it is the right rating, and our fuse is good. You can check the fuse in circuit on these, unlike the G07 with the F901. You have to check that fuse out of circuit, because even if it's blown, it'll still read good in circuit. This one you can check in circuit. So back to diode mode. Okay, so first thing we'll start with is all of our rectifier diodes over here. Meter in diode mode, negative lead on the side with the stripe. We should get about a 0.5 voltage drop. 0.551, 0.550, 550, 552, 558, 570. Okay, now let's go to R103 on the side here. R103 should be about 2.7 ohms, and we'll go to the two pads. We get 3 ohms. That's good. Good enough for our purposes. R104 should be 15 ohms, and we get 15 exactly. R101 should be about 4.7 ohms in circuit. It's a 6.5 k ohm resistor, but we're looking for about 4.7 k ohm in circuit, because if it reads about 4.7 k ohm, then we know our HOT is going to be good, or at least it's not shorted. If it reads about 4.2, then very likely our HOT is shorted. So we're looking for about 4.7, 4.8. Oh, hang on. And we get megohm. Megohm. Okay, just the legs are oxidized, and it's hard to get a good reading on oxidized legs, but yeah, there we go. 4.7, 4.8. So our HOT should be good, but we'll get to checking that here in a moment. Let's see. So R89 should be, that's this tall white ceramic one, should be about 3.9 k ohm, and we get 3.7. That's a bit low, but still should be okay. R96 should be 1.8 k, 1.789. R88 should be 1.8 k, and we get 1.782. And R97, I think it is. Yep, that should be about 270 ohms, and we get 269.2. That's fine. Okay, those are all the major components on the top of the board. We do need to check C38, which is our horizontal width cap right there. We're just checking to make sure it's not shorted, and that's these two pads right here. And we're 131K. Doesn't really matter what it reads as long as it's not shorted. That's all we're interested in. So now we'll go to our HOT, which is our horizontal output transistor, which is that guy right there. That should be about 4.5 in diode mode, negative lead on the middle pin, and to each outer leg should be about 4.5. I'm sorry. Yeah, 0.45 voltage drop. 0.48, okay, closer to 4.8. 4.8, and that's good. Now our critical safety cap is, and this one has a separate C36 and a separate C69. There's two individual caps in here instead of the 4-leg one. But just like the 4-leg one, we put our negative lead on this trace here. We'll zoom in a bit. And then across diagonal, we want to check our, it should be about 4.48, just like off our HOT, and we get 0.47, and cross again here, 0.48. So those two caps are good. D13 is also good, which is this diode here, just below the C38. We want to check our D15 and our C37 in here, because those can go bad and cause various issues. So D15 is good, so that means C37 is going to be good also. And last but not least, we can check our voltage regulator, this guy over here. We can check that easily by going to the B+ resistor on the side. We should get 180 ohms. If we do, our voltage regulator should be good. I don't want to say that it is good, because I've had some that don't regulate properly under load, but it reads fine on the resistor, so it should be good. But we're looking for 180 here, and we get 179.78980. So that's the main easiest way to check that. If you read 0 ohms, then your regulator is shorted. But if you want to do it the more proper way, we've got 1, 2, 3, 4, 5 starting from this side. And if we go to pins 3 with negative and 4 with positive in our diode mode, we should get a 0.150. Look at that, bam, 150. It should be about 0.45 voltage drop, but we're reading through the resistor, so that's good. Now, if you have this is the tall, skinny one. If you have the wide, fat one, it's pins 1 and 4. So you would go to pins 1 and 4, not 3 and 4, and you get the same reading. So that all checks out. I don't think I really even want to bother firing it up to see what it's doing. I think we'll just go ahead and cap it, reflow it, and kind of test both these at the same time. And as far as our remote board, let's make sure our pots are intact, which I already did previously, but sometimes it can be a little deceiving. You take a visual look and you see they're okay, but when you move them, you find out that the tab's broken or something. But those all seem okay. There's a little bit of solder on that. Not sure if that's been reworked, but it looks like somebody's cut these red and black wires and soldered them directly to the back of the board for some reason. I'm not sure why, but hey, you know, I mean, maybe they got cut or damaged, or I don't know, but we'll see if that works. So this one appears to be in good shape. Let's go ahead and test the second one, because we're going to work on both these at the same time. Now this one here has no remote board, but if we get that one working, we'll steal that one and use it for this one for testing. This one's likely still attached to the holder inside the cabinet. And it's a good idea when you have a chassis like this with these remote wires to go ahead and zip tie the harness here to the side. That way, while you're working on it and flipping it over and back and over and back and handling it, you don't end up with broken wires here, because you'll end up chasing your tail on those if you don't do that. I speak from experience. So we'll get that kind of zip tied there, and we'll do the same thing on this other one here. Okay. So this one appears to be in decent shape. I'm not sure what the discrepancy is with it. They probably just need it. They're probably just looking to get these two serviced, is what it is. Well, I didn't get a piece of paper or any kind of information that denotes what the issue with these were, but we'll figure it out as we go. Okay. So now, so now that we have the first one checked out, everything seems okay, let's check out the second one here. I'm going to breeze through this real quick because we just talked about how to do it on the other one. And of course, visual inspection is key also. I did the visual inspection on these already in the first preview video. So everything, just a general glance, looked okay. So now this one has been recapped. It's got Nichicon caps in there, except for this one, which, you know, I've got extra of these. I can change that to Nichicon. So these have all been replaced, it looks like. And I guess we can go ahead and put a Nichicon in C57, and then the rest of these are all already replaced and they're already Nichicon, so save a little bit of time for us. That's a 47. That's a 100. Yeah, I mean, well, this one's not Nichicon either. Not that it matters, but ultimately I'd like to have them all Nichicon. The bipolar caps have been replaced also. Have they? Yeah, so it looks like it's just C18 and C57. We don't put some Nichicons in there, but anyway, let's go ahead and breeze through here. So, good. Okay. R103, I'll just do it from this side. Gotta be careful because you touch the frame there, okay. See, I'm touching the frame. Okay, well, we'll do it this way. It always gotta be difficult. 3.0, okay. 15.3. 4.8, that's good. 268, that's good. Whoa, that's not good. 4.6, that's way out of spec. Should be 3.9. Well, we'll change that one. That's no good. So let's mark that with an X. so we can take it out and check it out of circuit. That's out of tolerance. I don't want to use that. All right, R88, 1.8, yep, 96, 1.8. We did 270, sorry, 97, that's 270. Okay, yeah, so 103, 4 diodes, 101, 88, 96, 89, 97. Okay, let's check C38. That's good. D13. Other way. That's good. D15. That's good. So C37 should also be good. All right, HOT. I'm sorry. Critical safety caps. That one's good. That one's good. HOT. That's good. That's good. Now we'll go to pins 3 and 4 of the regulator. 0.148. That's good. We'll just go ahead and make sure the resistor is good with 180 ohms again. And we get 170. That's a bit low, but good enough for testing. And this does have a replacement flyback already, and there wasn't any signs of arcing or anything, so I think they just wanted these gone through and serviced. But okay, let's take out, I guess, you know what, since this one has a fault or an issue, let's start with this one. It's already been rebuilt. Well, rebuilt, I mean, it's got a flyback and cap kit, but this R89 is no good. And let's remove this. And we'll test this out of circuit. And I've got replacements of these, but they're not ceramic, they're wire wound. And they'll work just as well. We got to remove this solder anyway to check the pads, make sure the pads aren't oxidized, and they actually look pretty good. But let's check this resistor out of circuit now, make sure it's still 4.5K, and it is 4.6K. So I don't like that, so we are going to replace that with one of these replacement R89s that I have. And if we look through here, that's what these are. I could have sworn I had more of these, but I guess not. But if you go to Arcade Parts and Repair, R1046 is the part number, but these are 3.9 5-watt wire wound as opposed to the ceramic one. But anyway, these will work for a replacement, so we're going to put in one of these. Okay. Let's fold that in somewhat like that. There we go. And really, of course not. There's always some kind of roadblock. Okay. Now we don't want this to sit all the way against the board or really touch any other component. Gonna have to get kind of fancy here. Because this thing gets pretty hot, so we don't want it to sit directly on the board or touch any other component. So, alright, I gotta get a little solder on the iron here, kind of hold it in place. Okay, that's good enough. Now, I think we can reposition this to roughly right there. I think that'll look pretty good. Then we can do this, just kind of hold it there. And then we'll do that side as well. Okay, now with that being done, it's not done, but that being replaced, Looks good. It's nice and secure, not touching anything else. I want to take this out and put a Nichicon in this spot. And somebody has, for some reason, moved that leg over like that. Okay. With 1,000 pounds of solder. Not sure why they did that. This pad and trace are perfectly fine. But now I need to get rid of this by heating that up, heating this up, and there we go. Now, we got to remove R101 because the pad here is severely oxidized. And if we look at the pad here, and I try to use a little braid, we'll see just how bad this is. Okay, you can see how the only shiny part is, well, I guess it's kind of hard to see, but the pad itself is all black around the perimeter here. So I want to just get my little sanding pen here and that's better, I must say. And again, we got this jumper wire here I'm going to take off, or try to anyway. Oh, this is part of that cap. Okay. Alright. Now let's check this solder joint. Oh, well, I was going to say not too bad, but it's so brittle that it just came off with the braid there, but that's okay. We have methods to counteract that. There that goes. So, with that being out like that, I ain't going out like that. I ain't going out like that. We can clean up the legs of our R101 here so our solder sticks to it a little bit better. Okay, nice and shiny. We'll get that back through here. Now see how hot this is here? That's likely from a bad connection. Over there it's not so bad. So this side had a bad connection for a long time and had high, resistance, which increased the voltage. But I wouldn't say increase the voltage. The voltage is constant, but it had high resistance there. So the high resistance heated up the trace and the pad. The voltage is the same. Pardon me. But the high resistance caused the pad to heat up and the trace to heat up and all that jazz. So you got to make sure. You ever see like pads burn up on the chassis because of a bad solder joint? It causes high resistance, which then burns it up. So now we can, that looks pretty good. Then we can just simply, ta-da! Now you don't got to worry about that in the future. Same thing here, we'll just go ahead and fill that up. That's not too bad actually for what it was. And we need to reinstall this cap. Make sure we do it the right way around, not backwards. Okay, that's good. let's... Oh. You rotten... You dirty rat. Let's make sure we can keep that in there. Okay, now that that's done, or reinstalled I should say again, we're just gonna bridge all this together. Nice, there we go. Don't really need to do this side, but we'll do it anyway. There we go. I mean, it's not perfect, but oh yeah, I mean, that's not perfect, but I mean, it's just more secure, and in my opinion anyway, and it looks a bit better than having that jumper across there. There we go. I think that should work. Yeah, it's not, I mean, it's not a beauty contest, it's just about functionality. There's a better shot of it, I guess. You know, sometimes the angle makes it look worse than it is, and of course when you clean it up afterward it'll look better. And I gotta redo this. Alright, so that's what I usually do for those, and then also down here for the other leg of R89 I kind of just do another bridge right here just for security purposes. There we go. Now again, this is a wire wound one and not necessarily a ceramic one, but that one was too far out of spec. Now if we check this one, should be right at 3.9. I don't want to say too far out of spec, but I don't like, if you read this and it's 3 point, like the other one was what, 3.7 or something, that's fine. With this being 4.5 versus 3.9, that's too far out for my liking. And if we test this one, we get 3.894. So, all right. Now let me grab. I want to change this one out here. Okay. Well, there's something down in there that won't let me. Alright, so that should be a 51, and the other one was a 47. So we need 250 volt 47, which I should have some here somewhere. Yeah, I gotta look for the 250 volt 47, but the 50 volt one, I have several of those. Okay. And the 250 volt 47, let's see here. 22s, 3500s, 1000s, 470s, 100s, there they are. Let me put these actually in the bin there. Okay. I knew I had them down in here somewhere. All right. So I'll grab this one. I just now realized that someone has loosened up the heatsink for the HOT, probably to change it out at some point. I don't know, but okay. Positive is this way. And then we have our 150. Positive is this way. There we go. Or 1 microfarad, I should say. Alright, so let's get those soldered in. Then we'll go through here and inspect and reflow anything else that we need and talk about life and anything else you want to discuss. All right. Okie dokie. Let's go through here and inspect. So one of the things you always want to look at when you're doing your reflow is R105. R105 here is the degauss thermistor, and it likes to burn up its traces because it's very thin from the factory, and these actually look pretty good. So I think someone's either actually already hit them or they were good from the factory, which is not always the case. But so someone's already done R103, all the video input header pins. There's some kind of chicanery going on here with this cap. They didn't cut the legs off of this one and folded them over because they tore a pad, but that's fine. Oh, same thing here. Look at this. Right there. Boom. Is that will that work? Yeah, I mean, sure, but that's usually a result of not using an iron that's the right, it's either too hot or not hot enough, and they're putting pressure on the pad and they break the pad off of there. So I run my iron here at 800 degrees Fahrenheit, which is enough to get in and get out. That's all you need. Flatback replacement looks like it's fairly decent. Yoke header pins are good. C38's good. D13's good. We did our R101, R89. R104 is another. This one here is another one you want to take special interest in. Your degauss connections, your header pins there are good. This all looks pretty good. I think that's it. Not much else we need to do, but before we clean it up, let's desolder the collector of the HOT, which is the middle pin. This will remove the horizontal circuit operation and prevent the horizontal circuit and the flyback from energizing, because we want to do our light bulb test to test our power supply section. Now, all of our testing indicates that this should work. However, we can verify that by doing this test. So if you're not comfortable with just removing or desoldering the collector leg of the HOT, you can remove the HOT completely. But in this case, I'm going to just completely desolder it. And if we put our meter in continuity mode and go to ground and then touch our trace, where's ground here? That's not ground, I guess. What's going on here? Oh, that doesn't go to ground, you stupid. It's been a long day already. I had to work all day, now I'm doing this. So let's go right here, and we touch our trace. Okay, let's touch our pin. Pin is not connected to the trace. So now we can power this up. We will not have high voltage energization. And we're going to go ahead and do our light bulb test and verify our B plus is at 130 volts. It's going to be probably closer to 129. Very few will ever get to 130, but we have our 60 watt incandescent bulb to simulate the picture tube load on the power supply. One lead goes to ground, other lead goes to the blue wire, which is the output. I just now realized that we're missing the zip tie that's supposed to be around here for these wires, which they all come apart because of heat over the years. Oh, that's better. Now, let's get our meter set up to read volts DC. And again, we can just go to ground here, like so. And then for power, we need another clip here. And we'll clip on the blue wire just like the bulb. And when we power this up, all of our indications are that it should work. So here we go. 1, 2, 3. Yes, and we get 100, and just like I said, 129.0. So you'll hardly ever see them get to 130, but that's perfect. That's completely average. It's nice and stable, not changing. Light bulb lights up, power supply, good to go. And with the light bulb connected to the circuit here, it discharges our filter cap, so we don't got to worry about any of that. Shocking you or nothing like that. That's on this version. Other chassis, you do have to worry about it. So it depends on what you're working on. But for the 7000, when you have the light bulb connected, caveat, light bulb has to be connected for the load to discharge it. It'll discharge just from the light bulb. All right. I think that basically does it for this one. I'm going to resolder that leg of the HOT before I forget. We'll get this cleaned up. I'll go through the other chassis and do everything I just did this one that you saw me do on this one, on that one. And then we'll be ready for testing. I need to turn the fan away. And we'll spray this puppy down here with some denatured alcohol. I like to use denatured because it cleans a bit better than standard isopropyl, and it's easier to clean up afterward, in my opinion. In my opinion, that is. And looking nice and good here. Man, factory fresh this is looking like. Okay, nice. So let's take one last look. It's nice and clean. And I think one more thing you want to reflow on this when you're doing your reflow is the interconnecting ribbon cable. There's a ribbon cable here that goes through to the vertical circuit from right here, and this one is black. A lot of them are gray. But this interconnecting ribbon cable, those solder joints like to crack and get thin, and there are these three right here. They jump over to these three right here. So from these three over to these three, and those all look okay. So, and of course your connections here for the neck board, those look fine too. So really just give it a good look over for anything and everything that might even possibly need reflow. That's all you really need to hit, unless you want to go through and do the whole thing. But neck board. Let's look at the neck board, and we're going to go through and set all of the neck pots to the center position. Wipe them back and forth so we can get a good color baseline. And the owner of this is going to have to go back and readjust his colors as needed for the tube he's using. Somebody had the green cutoff completely turned down, so that wasn't right. But if the tube is nice and healthy, all you'll need to do is just tweak these a little bit off center. So with all these dead center, if you have a nice healthy tube, the color should be great or somewhat perfect for the balancing. But if it's not quite, you can just kind of tweak these as needed a little bit. But if you got to turn one completely up or completely down, then you've got tube issues. But we'll start like that with this, with all of them set to the middle. And it looks like somebody forgot to replace the... Oh, no, they didn't. That's a replacement 4.7. Okay, yeah, I guess that's fine. We'll leave that one in there. The color transistor solder pads, none of those traces are broken or lifted. All right. And one last thing here is I like to... Nobody ever seems to fold this wire in there like it's supposed to be. And I like to take this ground wire here and zip tie it to the harnesses here, because what will happen over time is that the ground wire will go back and forth and break off the solder joints. So I like to put a zip tie on there to act as a strain relief. So that'll give you a little bit of peace of mind, so you don't have to worry about that ground wire breaking off and giving you problems, because you never want to run this without the DAG ground connected. Never. So let's move our resistors out from touching each other, because if they touch each other, they'll induce heat upon the other one, cause premature failure. And that all looks okay. Solder joints look fine, so I think we're good. In our replacement flyback, you see there's two of the same color wires come out the top, or actually one out of the bottom, one out of the top here. This is our anode wire, but there's this wire here is our focus wire. This right here is our G2 wire. Normally these are different colors, but on this one they're the same, so you never want to go off color. Your thick wire, the thick wire is always your focus wire. The thin wire is always your G2 wire. So disregard your colors when you're changing the flyback. Thick wire is focus, thin wire is G2. That's the rule of the land. So, all right, with it clean and checked out. Oh, we got to remove this, whatever this is, like thermal paste. Somebody put thermal paste on there for some reason. And we also need to, no, I can't steal this remote board because somebody soldered the wires to it. I need to grab one of mine here, and I have a lot of extra junk. As you can see, I have plenty of the alternate 7000 remote boards here. Crazy. But I do have plenty of 7000 remote boards too that need replacement pots, which I have those, but I do have one in here somewhere that is complete. You can see that these get smashed over the years. I didn't do that. This is just kind of how this stuff is sitting in here. Somewhere in here I have a complete 7000 remote board that doesn't need any work to it. That's a 7200 remote board. That's a 7200. I'm not sure where it's at, and honestly I might have used it. I gotta dig through here. Let me dig through here and find it. I'll be right back. Hang on. Well, I didn't actually have one, so I used one of the boards that had a bunch of broken ones, took them all off, threw them away, and I made a brand new one here with the updated pots. So I will have this for the future, but for now I need to clean that driver off, and I need to turn all these to center position just for starting. Close enough for government work. Let's plug it in. There we go. All right, so this is mine. It'll stay with me. But for now, let's clean this up. The only thing really up to this point is that was bad was R89. And let's clean off this thermal grease that's on here for some reason. I mean, that's what this is, there's no doubt. But why it's on here, I don't know if somebody confused this with dielectric or really what, but this is not what should be on here. Okay. That looks fairly good. All right, well, one is down and ready for testing. This is ready for testing for all intents and purposes. So we'll wrap this puppy up. And I'm going to do everything that you just saw me do to this one. I'm going to do to this one. So get that done. I'll come back. I'll show this one off because this one has not been serviced. Original flyback, original caps, all that jazz. The flyback itself has A little bit of a crack across the front, but that's completely common for these. Nothing to worry about. The whole front of this, everything forward, well, it's actually cracked up top here too. Everything forward of this area here is just like the plastic casing. We'll zoom in here a bit. You can have cracks along here in the face and all, because everything forward of this piece, there's a bunch of potting on this piece that separates all of this from the windings and the rest of the high voltage. And sometimes it'll come through that potting and arc out of here, but that's due to failing of the potting. But as far as this thing here, there's no actual high voltage in this part, because if there was, we would have high voltage leaking out of this crack absolutely with absolutely guaranteed to come out of here. But if we fire this up, there's no high voltage coming out of this crack. That's because this whole faceplate here is not actually part of the high voltage circuit or high voltage system inside the flyback. It ends up to this point here, this and potting in there. This is to the best of my knowledge. If I'm wrong, you can correct me in the comments. But that's why you can see that's why you can see cracks on the face of these 7000 flybacks and have them still function. Because if there was high voltage leaking into here, it would leak out of the face and arc right to the side. So when you see cracks across here, it's not really that something to worry that much about. Only if it's leaking. If it turns on, functions, no high voltage leaking, has good solid focus and lasts, we do not change these out, because the replacements are no guarantee to work. They may last 5 minutes, 5 hours, 5 days, 5 months, 5 years. You don't know. It's a gamble. So I don't replace these unless I absolutely have to. So we'll fire it up with the replacement on there and see what happens. Now this is one here, like I say, it's already been replaced, so hopefully it works. But I'm going to do everything you just saw that I did to that one to this one. When I come back, we'll give this a good overview, and then we'll fire it up on the bench, both of them, and see if they work. Actually, real quick, I was given this a better, closer inspection. Some of you may have noticed this previously when I first showed it off, but when I did these, I took it out of the wrapper, and I was going through, or out of the bubble wrap, and was going through these. I gave them just a quick cursory look over, but now going through and doing a much closer, thorough examination. I mentioned before, inspection is important. Before I began working on it, I started grabbing caps and everything. I noticed that this is probably dead. And the reason it's probably dead is because of this right here. Now, I had mentioned before that bad solder joints increase resistance, which heats up the pad and burns things out. And I think that this is probably part of our problem, because that's not even in the circuit. I don't know how close I can get in here, but that is not even soldered in. Look how broken that is. I'll bet you there's not even continuity across there. And with that out of circuit, you'll see that just happens to go up here to our horizontal yoke winding. So this is our vertical, the closer ones, and the further apart ones are horizontal. With no voltage from the flyback getting through our horizontal circuit, you won't get anything. So I'll bet you this was dead, and because of that right there. So again, that's why inspection is important. Inspection, reflow, all that. So meter is in continuity mode. Leads are good. If I touch the next point on the trace and go to the pad, if I touch the pin, nothing. Nothing. If I push a little bit, maybe, push a little daisies and make them come up. A deep cut for you. We'll push the pin. Yep. So, yeah, I just want to point that out before I continue on. So I'll continue on with the cap kit and reflow, and we'll fix all this up. And when I come back, this should be done and ready. Unless something else I find pops up, we'll just continue on with this and see how it goes. Okay, just like that, the second K7000 here is all done. We already tested all the components, everything checked okay. Did the light bulb test off camera, that passed. Full cap kit, full reflow, everything that we talked about and did on the other one is done on this one. We got the major components done. I got the flyback re-soldered here along with that bad joint. We got R101 taken care of, R89, R104 degauss thermistor, video input header pins, the cross ribbon cable I talked about, yoke header pins, yeah, the whole 9 yards, got it all cleaned up, we're good to go. Neck board as well, took care of that, did the zip tie I talked about, and we got the remote board here that's soldered on still for some reason, so, and I got this removed, not this, I got the thermal grease removed, thermal paste removed, and I also removed this little washer here that really doesn't do anything. You don't need it. The new flybacks don't even come with it, so in the garbage that goes. So we have two freshly rebuilt K7000s. I assume this one's going to work because it just had the bad solder joint on the flyback that was keeping it dead, is what I'm assuming. I didn't see anything wrong with this one. Maybe it wasn't working because R91 was out of tolerance, I should say. Not out of circuit, it was out of tolerance. So I'm going to grab a picture tube. We're going to hook these up. We'll hook up this one first, this one second, give them a test and adjustments and everything, and we'll see how it goes. I did forget to mention that I also got all these pots set to the middle position. If they're cleaning those, wiping them back and forth, all that jazz. So yeah, let me grab a tube. We'll get these hooked up. This one will be hooked up first when I come back and ready for testing, and we'll move on to this one. If nothing is wrong, then we'll call these good, and we'll move on to something else in the list. And we got 2 out of the 9 done, and we'll see how it goes. Okay, so 7000 number 1 is all hooked up to, I have a U5000 tube here that we're using for testing, so this has to sit kind of on this protector here so it doesn't short out. And when I was trying to hook up the anode cup, the original one just basically disintegrated on me. It's just hard as a rock. When I tried to fold it back, it just broke right off. So I had to kind of splice in a replacement one here. And what you do here is you just cut it, strip it, solder it together. Now in the joint there, you put some hot glue, wait for it to dry because you want to fill the gap in the wire. So when you bend this, there's a little strain relief in there. Then when you heat up your heat shrink with your hot air gun or whatever, that glue will then re-liquefy and hold the form of inside there with the heat shrink. So now when I bend this, it doesn't bend at the solder joint, it bends down here at the bottom. So that's nice and rock solid. So that's how I recommend doing that in the future if you ever have to do that. But as you can see, that is a successful splice. When I try and bend it here, instead of bending at the joint, it bends right there. Good to go. So we got that repaired, and we're going to turn this on. I got my trusty Mortal Kombat 2 PCB for real world video and things like that, as opposed to a TPG. And replacement remote board. And yeah, let's turn this on, see if it even turns on, what it does, and we'll go from there. 1, 2, 3. Okay, comes on, no immediate arcing or sparking. And what do we get here? Nothing yet. Nothing yet. Do we have net glow? Oh yeah, plenty of net glow, but no image. Is it simply because we got to turn up our flyback and or brightness? Yep, there we go. Awesome. Okay, well, now that we know it's working, we don't have collapse or anything, and it's fairly good. Let's go ahead and get the camera on the tripod, make some adjustments, see how well we can make this look. Okay, can I zoom in a little bit, get that little refresh rate a bit better? Maybe not, but yeah, that's pretty washed out for now. So what we'll do here for this procedure is we will turn brightness all the way down, contrast all the way down. Let's turn up our flyback until we no longer, or until we have raster lines, that is. Retrace lines, not raster, retrace. There's our retrace lines back down till they just go away. Now we will supplement our brightness back up until the background is no longer black, which is right here, and then back down till the edge of our raster is right there, so till it just goes black right there. We'll turn up our contrast as desired, and hey, there we go. Now let's adjust our focus because the focus isn't any good, and glorious. Okay. Now let's go ahead and gotta zoom out a little bit. Okay, let's go ahead and adjust vertical position. Actually, let's go into the menu here. We'll do it this way. Okay. Now, diagnostic test, monitor patterns, crosshatch. Okay, we're way too wide, but that's okay. We do have a little bit of linearity, but not too bad. Okay, vertical position. I guess there, vertical size. We'll go there. Position back down a bit. We want the red part of the block to be just slightly touching the top and bottom of the visible tube, and that is pretty pretty good right there. Okay, H position. That is right about even there. Now let's adjust our H size coil. Make sure it functions, and we have adjustability. Okay, here we go. And the tool is just spinning in the coil. Yep, okay, well, oh, I can see that's because it's broken. So somebody tried to adjust this and they broke the ferrite core, and that's all you get. So I'll get with the owner and ask him if he wants me to replace the width coil. Until then, we're going to just consider it not adjustable, but that's not a big deal. And we're a little bit too bright. We'll go back down to there. Contrast, that needs to come down a bit. Brighten this up. Now, what do you think about that? You think that's any good? Now, of course, this always looks much better in person. It looks a little bit too blue through the camera of the iPhone here, but and actually we need to turn down our vertical size roughly there. That's not bad. And it seems like we have a little bit of horizontal linearity going on here. And if we go to the game here and start the game, it looks pretty good. Again, it looks much better in person than what you're seeing through the camera here. It's just the camera, the exposure here. I wonder if I tap on the screen, maybe it'll, yeah, it looks so much better in person. But I have to say, yeah, not bad. And the owner of this is going to have to go through and adjust all their colors, and again, screen size, position, shape, and whatnot for X-Men. But, you know, speaking of which, I do have an X-Men PCB. However, it's not the 6-player. But just for the sake of curiosity, I'm going to hot swap this over to X-Men. Now, X-Men has a much higher video output, so we'll likely have to turn our brightness down. Holy crap, yep, vertical hold. H hold needs adjusted a little bit. We'll have to hit that because the top's a bit wonky. And that's not bad, I guess. So Cyclops.
In the 21st century, evil mutants led by Magneto Agent destroyed.
Well, that's pretty good. Look at that. Wow. Now, I can't adjust the horizontal size, but I'll get with the owner and see what he wants to do. But hey, that's pretty good. I dare say we have a functional, working, good K7000 here. So I'm going to turn this off. I'm going to hot swap over to I guess obviously turn the power off, not hot swap them, but I'll take the other 7000, put on here, and we'll see if that one's as good as this one. Okay, so 7000 number 2 is now hooked up to the test tube. Everything's connected, anode, neck, yoke, ground, power, video remote. And the remote board, I went ahead and set all the pots to the halfway position just for a nominal setting. And again, this is the one with the wires soldered to the back. I don't know why there's plenty of wire there to solder back onto, but hey, you know, if it works, we'll leave it like that. And this is, of course, is the one that had the cracked face on the flyback. And again, that's not really an issue, and which, you know, if this works, you'll understand what I mean. It worked just fine. And yeah, all the color pots are centered and everything. We talked about that. So this should work. This is the one I just got done capping and redoing. So fingers crossed it fires up and works like the last one without any issues. So, and then hopefully that width coil is able to be adjusted. We'll find out if it works. So anyway, okay, so here we go. 1, 2, 3. Okay, it comes on a lot less energetic than the other one, but nothing's exploded or shorting just yet. And what do we get for this one? Nothing yet. Brightness up, contrast up, nothing. Do we have neck glow? Oh yeah, plenty. Huh. No image. Does the flyback need to get turned up? Let me see what I can do here about that. I gotta clean off this screwdriver here first real quick. All right, sorry, all right. So let's see if adjusting this does anything. Nope. No. No, no. So we have no image. Interesting. That noise is just the PCB here if I start the game. There you go. Well, let me do a little oh, that was, I just saw, if I turn this back on, watch what happens when I turn it off. 1, 2, 3. Oh, we get something. It's almost like it's collapsed. Something's not happy. Well, let me do some troubleshooting, see what I can figure out and determine, and I'll come right back. Okay, so I found at least part of the problem. It's not something we normally check on our power check circuit. You really only check these components when you have like vertical size or vertical collapse issues. I did mention how when we turned the monitor off, it did kind of look like it was collapsed. So I went right to R91, R92, D13, D14, the 2 diodes in here and the 2 resistors. R91, R92 should both read 1.2 ohms in circuit. And as you can see here, this is R91. Yes, this is R91. And if I check R91 here, it's going to be difficult with one hand, but I will try. If we check R91, it's completely open. Nothing. R91 is completely open. So I replaced it. You get an idea in there. It's right in there. So R91 is now replaced. It reads 1.3 ohms in circuit. So it opened R91. Now, I don't know if that happened when we turned it on or it was like that before. It might have been something to do with that pin not soldered in on the flyback. But regardless, I got that done. Let me get this back on the tube and we'll try it again. All right, we're all hooked up again. Take 2. Let's see what happens. 1, 2, 3. Man, it doesn't really have much. Oh, smoke. We got smoke. Gosh. Well, let's see if I can figure out what caused that. Okay, so it turns out that R91 was burning up. That was the component that was smoking was R91. The replacement R91 we put in there actually started smoking. It still checks within spec, and it's still good because we turned power off before it completely burned up. But the original must have smoked for a while because it was already completely open. But the reason our replacement R91 was smoking was because D13 was completely shorted. Now, if you recall, we had kind of a collapse as we turned the screen off. We saw a little bit of collapse there. And it turns out the reason that R91 smoked up was because our D13 was completely, totally shorted. Now, we don't normally check D13, D14, R91, R92 when we do our power testing and everything, or other testing, because we really only mess with these if we have a vertical output problem. But if you recall, when we shut the monitor down, we had evidence of collapse there. We had that solid line across the screen, and that makes sense because of D13 being shorted there. So with that being shorted, it took out R91 originally, and then it smoked our new one, which actually is still good, and caused collapse. So with this being replaced, I put a brand new one in there. The check's good, no issues, everything should be good now. So I'm going to fire this up once again. And let's go ahead and see what we get here. 1, 2, 3. All right, we get a little bit more energization. That's good. Do we get any kind of picture this time? And yes. We need to make some adjustments here. Okay, let's go ahead and get the camera on the tripod here. Let's start, of course, with vertical hold. All right, there we go. Vertical size. Oh, what's going on there? Vertical hold pot is touchy. There's something going on here. Yeah, there's something going on with our... What in the world? I think it's probably a bad connection, but let's start with vertical position. Okay, vertical size. All right, let's adjust our 50-60 hertz pod a little bit to try and get the vertical position to shift up a little more. If I can find my screwdriver, here it is. All right. There we go. Vertical size back down. Now that looks pretty good, actually. Okay, now let's do our brightness all the way down. Contrast all the way down. Screen pot up until we get retrace lines. Oh, I don't get retrace lines. Huh, interesting. Well, okay. I guess we'll forego that for now. Oh, yeah, there's definitely some problems with the wiring on this remote board, but that looks pretty good, I must say. A little degaussing in the corner we need, but colors, all the colors are dead center in their adjustments, and as you can see, it looks fairly good. If we had a decent camera operator here, there we go. Sorry about that. I don't know how long that was messed up. I apologize. But yeah, looking good. So, all right. Let's adjust our horizontal size. You don't always get retrace lines with these older flybacks. So, this coil looked okay. The core did anyway. And let's see if we can adjust this one. This one's frozen in place. I can't win with these. Yep, I can't turn that one. Let me see if I can work some magic here. I'm going to use a metal one. Never, ever, ever use a metal Allen key to try and turn this with coil. But okay, I successfully broke it free, and let's use the plastic one now again, and there we go. Bring that puppy in, and that's about the limit that we can bring it in. And let's move each position here over slightly, and there you have it. We have 2 for 2. Not sure what's up with this stupid tripod here, but anyway, let's... Okay. Yeah, not too bad. This looks so much better in person. I say that every time, but man, it looks dull and washed out through the camera, but in person it's amazing. So there you go. We are 2 for 2 on these X-Men 6-player 7000s, so I'm sure the owner of this will be happy. And I will continue on with the rest of these. We're 2 out of 9 so far. And stay tuned for the next part, and we'll see if we can get the rest of these going. So thanks very much, and we'll see you next time.